Hi, my name is Rasmus Krislund, and I'm an external lecturer at the Connectivity section at Aalborg University in Denmark. In this short video overview, I'll introduce smart metering and try to make it clear why wireless communication is such an essential part of this application. I'll start off by introducing smart metering, then describe what makes smart metering smart, and finally, I'll give some examples of use cases where we put the data from smart meters to use. First, have a look at this very simple illustration of a distribution network. For example, clean drinking water. We have the utility below, and the lines are then representing the pipes in the ground. And the dots are meter points, meaning this is where we have the residential homes, apartments, industries, any address where water can be consumed and where we have a smart meter installed. This meter then measures the flow and volume and maybe some other parameters as well of the water running into this address. And the sample values are then transmitted wirelessly. These transmissions are collected by a fixed infrastructure deployed by the utility itself or maybe some third party. This network will have base stations installed at strategic locations throughout the area to be covered, creating a coverage for all the meters in the network. In this way, data is automatically collected and will be rippling in continuously, made available to the utility for use in their day-to-day operation. And this is in high contrast to the situation where the utility is manually collecting the data from each meter. The value from the data actually comes from the amount of data. To charge the end user for a given amount of consumed water, maybe yearly or monthly, does not require much data, and it's not much additional value you can extract from this data when you only have these very rare samples. But when data is continuously rippling in from all meter points in the distribution network, the data enables a range of other use cases representing significant added value to the utility. And the relationship is actually as simple as illustrated here. The higher granularity we have in the data, the more added value we can enable. I usually also explain this relationship with this simple triangle, which is loosely inspired from Maslow's hierarchy of needs. If a utility wishes to act upon data, for example, perform various improvements in the production of clean drinking water, they need to be able to identify certain patterns related to this optimization that they wish to perform in the data received from their smart meters. And these patterns can only be observed if the consumption across the distribution network is continuously being monitored in order to create a strong, detailed foundation of data. But let's have a closer look of some of these use cases. Pipe bursts, like the one on this picture, are something utilities seek to avoid. As you can imagine, they are quite costly, not only due to the amount of water that is spilled, but also due to the damages it causes to roadwork, to buildings nearby, and so on. The risk of bursts tends to increase with the age of the pipe, so utilities have previously maintained their distribution network on a first in, first out basis. They simply have been replacing the oldest pipe segments first. But there's another parameter that comes into play when it comes to bursts, and that is the experienced load and stress over time. For a segment in a water distribution network, this could be the water pressure and the flow it has endured. When a utility has smart meters distributed throughout the distribution network, not only at the end users but also on the main pipes, it suddenly becomes visible to the utility where there's been high water pressure and a high flow throughout the network. This makes them able to do predictive maintenance because they can estimate which pipe segments has the highest risk of bursting, and then they can target their maintenance resources to these particular segments instead of just blindly replacing the oldest pipes first. Maintenance becomes in this way more cost efficient, and large bursts like the one we have here becomes less likely. But large bursts like this are actually not the most common source for water loss. We have a parameter that is called non-revenue water. This refers to the amount of clean drinking water that is produced but never billed. It means that it's never measured. Non-revenue water therefore covers the water that is lost in large bursts like the one we saw on the previous slide, but also any other small leak in the distribution network, in pipes or in assemblies. The majority of all leaks, actually up to 90%, are never visible at ground level, so the water simply disappears into the ground. This means that part of the energy that we use to produce clean drinking water is wasted, and so is the water that could have been put to good use at the end user, but instead is sipping into the ground. And as a result, the cost of producing the water that is actually consumed by the end user increases. On the figure to the right, you can see that some countries are actually struggling with a very high level of non-revenue water, meaning that the cost of the water actually consumed by the end user is much higher than it would have been if the level of non-revenue water were lower. With the continuous stream of data sampling the amount of water running into a pipe segment or a section in the distribution network, and also samples of the water running out, it's possible to locate and fix even small leakages in the network, and in this way reduce the level of non-revenue water. The final use case I'll touch is cost optimization. Not only for the utility, but also for us as end users. Because it can be difficult to relate to a yearly or even a monthly amount of consumed water. But if we are presented with a detailed overview of the water consumed through the course of a week or maybe a day, we automatically start correlating the consumption with the activities that we have had at certain times of the day. Suddenly it becomes much easier to identify what in your daily routine costs a lot of water. The main potential for saving water may not be the morning shower, but instead the food preparation in evening, or maybe the way you do the dishes after dinner. The utility may identify periods of low consumption throughout the network. In these periods, it can reduce the pressure in the pipes without compromising the user experience to the few active users there may be. And when it comes to water distribution, user experience is when, a good user experience is when water is pouring out when you open the tap. When there's only a few users, you can do with less pressure in the pipes and still have water pouring out. Reducing the pressure means that the pumps can be turned down, and this saves energy and reduces the operational costs for the utility. Common to all these use cases is the amount of data that they require, or more specifically, the granularity or the resolution of the data that is required. And this actually adds another level to this triangle of needs, because the more data that is needed, the more robustness is needed from the wireless network, that we use to collect these data transmissions from the meters. And from this 4 levels in this triangle, we can see that the reliability of the utilized network becomes the foundation of whatever the utility wishes to do on top of the data. And I'll give a quick overview of the fundamentals of wireless communication in another video. But just to sum up of what we've been through today, the continuous flow of data samples and the intelligence that we put on top of the metadata is actually the smart in smart metering. And the wireless communication that we use for continuously collecting these data samples becomes a key enabler for smart metering. And the typical use cases for smart meter data presented here put certain requirements on the reliability and the latency on the utilized wireless technology, which is why one has to be very careful when selecting the wireless technology to be used in a smart metering system, because you need to ensure it fits the needs that you have or what you want to do with the data. This was all from me for now. Thank you for your attention. Stay tuned for more videos from the connectivity section.